Let me start. There it goes. Okay, so graphing exponential functions. We started learning about exponential functions this week. So long ago, yesterday, we learned about constructing exponential functions. All right, and so, I might reference the pair deck from yesterday as we go through this, but today we're moving on to the next lesson in the module, which is 15.4 with your text. Your EQ, how do you graph an exponential function of the form f of x equals a times b to the power of x? So when you are not provided tools to type exponents, this means that this is the exponent x that's up here with this b. Okay, so that's what that means. If you ever see that, which sometimes you would see that, that's what it means. Your learning goal, I can graph an exponential function. Very straightforward here. All right. So this slide here, this is fun. Here's what we're going to do. We're going to use Desmos. We're going to use the graphing calculator to identify which graph goes with which exponential function. So this is like a matching little thing here. You can't draw on this slide, but you can use Desmos to type in these 4 equations, and we're going to see what they look like, okay? And it's going to be one of these 4 pictures here. These pictures are really grainy and gray because these are what I used in high school, which was a graphing calculator. And I still have my graphing calculator, and you can still use a graphing calculator. Maybe you have one. But yeah, the picture is black and white and it's kind of grainy, but we're going to use Desmos, which is so much better. So what I want you to all do is come in here and we're going to type each equation. So in your pair deck tab, go to your pair deck tab and start typing. Okay, the first one is y equals 3 parenthesis 2 close parenthesis, and now I need to do the exponent of x. So I showed you this yesterday, but just in case you forgot, to do an exponent when you're typing, we're going to come down to the keypad, click on it, and there is a button in the top row, 4 buttons over. It says a to the b, a to the exponent of b. Click that, and your cursor will move up to the exponent area. And now you can type x. Boom, look at that. I have a graph. And now you're going to go and click below and type the next equation. Y equals 0.5. Open parenthesis. 2, close parenthesis. Hit that button again, a to the b power, x. Look at that. So these are different. One is more to the right than the other one. One's more to the left. They're crossing the y-axis in different points. And so if you're looking at your pictures here, you can figure out which one is that and which one's the other one. So we're going to type all of these in. You need to type all of them in. Y equals 3, 0.5, all to the x power. Next one, y equals -3, 2, all to the x power. Oh, that's not right. So if I put my x and I don't do exponent, that's what happens. So if you get something like this, that's a mistake. All right? These are not linear graphs. They are exponential graphs. All right. So now I have all of my graphs shown. All right. So let's see how you guys are doing with this. I have to go into GoGuardian to see what you're doing. So everyone should be over in their Desmos. So don't be on the Meet right now. Be in the Pear Deck. Go to the Pear Deck. and you're typing in these different graphs. Some of you are still in the meat. Go to the Pear Deck. I want you to be in the Pear Deck and type these in. You need practice using Desmos to type in different functions because it is a really excellent tool. It's way better than a graphing calculator that you'd have by hand because technology is awesome. Okay. Once you have those, you could toggle all those lines on and off. You have the colorful circle with the little white squiggle. If you click it, it makes the graph disappear. If you click it again, it makes your graph reappear. Okay? So once you get these all typed in, what I want you to do, and I'm going to put you on student paste. Okay? So as soon as you get them typed in, you're going to go to the next slide, slide 4. And I want you to draw on this slide now. It's the same matching problem, but now I want you to write what letter goes with what number. Okay, so for example, if you come back to the meet, I'll show you for the first one, number 1, if I turn off the graphs of all of them except the first one, okay, and I'm just looking at that one, this one matches. If I look, this one's going upside down, this one's going the other direction, this one's too far low, this is the right one here, it's A. So number 1 is A. So what I'm going to do is go to slide 4, and either with the text tool or the drawing tool, I am going to put a, not a dot, resize that. I'm going to put a lowercase a next to number 1 because I found out that this is number 1. Okay, that's what you're going to do on slide 4. You're going to go back and forth between slide 3, turning on and off your graphs to figure out what they look like, and coming back to slide 4 and write in what letter each one is. Okay, so I'm going to kind of see how we're doing. I'm going to show our responses. We have 7 of you that have started writing on slide 4. Oh, look at this person. They're so clever. I like how you guys came up with different ways to do this. Both these people. So come back to the Google Meet. I'm going to totally take, and this person too. So I told you guys just write the letter. But like this person drew lines. This person color coded it. That's lovely. This person circled it and then circled it, like color coding it as well. So there's lots of ways to match it up. I like that. I like the color coding. So if I go back to my slide, if I turn these all on, okay, you're just matching them with the one they go with. And so let's see if we have it correct. Again, I want to go to the 4th slide and see, oh, this person's color coding with highlighter. I love it. Some of them get a little crazy. This one got a little crazy with the lines, but yeah, this one's good. So far, like if I go this way. So if you do draw lines, thin lines are the way to go because this is easier to see. And this is correct. If you color code it like this, number 1 is A, number 2 is C, number 3 is B, yeah, number 4 is D. This works. I like that. You just write the letters A, C, B, D. Perfect. A, C, B, D. They typed it. I like how there's so many different ways you can do it and it just all works. This is really fun. Red to red, yellow to yellow, green to green, and blue to blue. That works. It's perfect. All right. Awesome. It's being recorded, so if you don't have that down yet, don't worry. You can always go back to the video and get it. We're going to move forward, though, to slide 5. Okay, so on slide 5, I'm just explaining to you how to do this. So go ahead and jump forward to slide 5. I'm probably going to turn off student pace for a little bit. Okay, just because I want you to be on this slide and seeing what we're doing here. So either come to meet and see what I'm doing or just stare at slide 5 on your own. But this is showing us how to graph increasing positive exponential functions. So we have the symbol infinity, which hopefully you've seen before. It's an 8 on its side, and that's the infinity symbol. We can describe the end behavior of a function by describing what happens to the function values as x approaches positive infinity. Coming back to our chat. Sorry, I got sidetracked. Okay. And so x goes to infinity. That's how you could write that. As x approaches negative infinity, that's how you would write that. And so to graph each exponential function, for this example, they're doing these multiple things. They're graphing, they're identifying A and B, the y-intercept also, and the end behavior of the graph. So for A, the function that is given is f of x equals 2 to the x powered. Now, Desmos is great because you could type this in and make sure you're doing all your work correctly. You would get a picture like this if you are. They're showing you how to graph this by making a table of values, which is always a way to graph something, you know, whether it's a linear equation or an exponential function. You can always make a table of values and put some x's in there and graph it. Now, this is different than yesterday because yesterday our domain was limited, okay? Yesterday, we had like a limited 6 points. That was the entire function. Now, today, there's no limit on the domain. So they're saying just choose several different values of x that you can work with, plug them in, and see what you get. So, for example, if I put -1 where x is, this is the same thing as 2 to the -1 power, which is 1/2. That's one of our rules for negative exponents. If I put a 0 in, 2 to the 0 power. Anything to the 0 power is always 1. That's why we get 1. If I put a 1 in, 2 to the first power. Anything to the first power is always itself. That's why we get 2. If I put a 2 in, 2 to the second power. 2 times 2. 2 copies of 2 is 4. All right, so we have these ordered pairs. You can plot them. But then after we graph those ordered pairs, it says connect them with a smooth curve. We did not do that yesterday. We only do this when our domain is not limited. Our domain is not limited here, so we can connect the dots. Then they're identifying A and B. When they talk about A and B, let me show you. They go back to yesterday's pair deck. Right here. So this is what they're talking about, A and B. F of x is equal to A times B to the x power. Okay, so A and B are the two numbers that are here. Well, we see B. B is 2 because that's what's the base of x. So B is 2. The reason A is 1 is because I don't see something here. I put a 1 there. You can always multiply by 1 and not change the value of something. So if you don't see that extra number there, then it's 1. They also identify the y-intercept. So multiple ways to do that. One way is to look at the graph. Where does it cross the y-axis? right here, 0, 1. Or look at the table where x is 0, y is 1. That's the y-intercept. Another way is that a will represent the y-intercept of the function. Okay, we know a is 1, so the y-intercept is 1. It refers to the y-coordinate, 1. So you can write it as it equals 1 or as the ordered pair. Means the same thing. And then the end behavior. Okay, what does this graph do as it continues on to infinity, the left and to the right? So as x values approach positive infinity, as x approaches positive infinity. Okay, so as we go this way along the x-axis, what's happening to our graph? The y values approach positive infinity too. They continue to move up towards positive infinity. And then as x values approach negative infinity, which is in the negative direction, as x approaches negative infinity, if you look along the x-axis, as we go further and further towards the left, towards negative infinity, our y values approach 0. Okay, if you look at the graph, it's getting closer and closer and closer to the x-axis. It's getting closer and closer and closer to 0. It'll never touch 0, which is like weird to think about, but it's true. Okay, so if you think of it like this, here's this thing and this thing. I'm trying to get these two things together, and I go half the distance, I'm here. Now, if I'm trying to get over to this point and go half the distance, I'm here. I keep going half the distance, half the distance, half the distance, half the distance forever until the end of time. I will still never, ever, ever get there because half of something is always something else until I get to, no, you won't. It approaches it, but you'll never actually get there. It's a really weird thing. So that's what's happening here. Y is approaching 0. You're never going to get to 0. You'll get infinitely close to it, but never there. Okay, so yes, you can argue about it if you want to, but anyhow, that's how we do that. Now we're going to do this last slide together, and that'll be it for the pair deck. And time-wise, where are we? Let's see. I'm always so like messed up on Wednesdays. So we started at 11:45. We have till 12:30, so I have 21 minutes to do this slide with you. Hopefully it does not take that long. All right, so you want to have the meet window open, you want to have your pair deck window open, and that way you can copy along as we do this together. Okay, so right here, f of x equals 3 times 4 to the x power. This is the function. If I want to graph this function, one way is to create a table of values. Another way is to use Desmos. Okay, so we're gonna use the table of values here. We're gonna use Desmos to check our work, but we're not gonna use it to graph on this problem. So we're gonna choose several values of x, which they've already done for you, and these are really great values to choose for an exponential function. And we're gonna generate ordered pairs. So I am going to type out the function, but I'm going to replace x with -1 first. So we have f, no, not in black, that's not green, here we go. F of x, but instead of x, I'm going to write -1 equals, we have 3 times 4 to the x power. 3 times 4, x power. Okay, I can't really write that exponent, so you could do the little like arrow thing and type it in that way if you want to, if you understand that, but I'm just gonna switch over to the pencil tool and write in 1 that is negative, like that. Okay, now we got to use our rule about negative exponents. 4 to the -1 power, and we're doing that before we multiply in 3 and 4. Don't multiply 3 and 4 first. Okay, you guys, I'm gonna put this over here so you don't forget. PEMDAS, order, parentheses, exponents. You have to deal with exponents before you do any multiplying or dividing or adding or subtracting. So we're always going to deal with exponents first. Let's change my lovely green to yellow. That's interesting. 3, that's just tagging along. But now instead of 4 to the negative 1 power, that turns into 1/4. 1/4. That's the rule for negative exponents. And then we multiply 3 and 1/4, which is 3/4. You can leave it like that, or you can put it as a decimal. 3/4 is the same as 0.75. Right? It's up to you if you want to. Oh gosh, it's up to you if you want to write it as a fraction or a decimal. But over here, write it one way or the other. I'm going to write it as the decimal. And we're going to plot this ordered pair. So the x coordinate is -1, the y coordinate is 0.75. All right, so take a look at this graph. Our x-axis is going in increments of 1. The grid goes in increments of 1. Okay, 0, 1, 2, 3, 4. Our y-axis is completely different. Our y-axis is starting at 0, and then 2 squares up is 15, which means 1 square up is half of that, 7 5/10. Half of a square is here, which is under 4, and half of that is under 2. And I'm still trying to get to under 1. So I am like so close. So if I go to -1, I'm really, really close to the x-axis for this point, right? If I'm going fast, put stuffs. How do you power a number by a negative again? Okay, good. I like when you guys ask me questions. So right here, what I did, and I didn't really show it, just because it's green. Oh, no. Here. Okay, so 4 to the -1 power is equal to, what you want to do is you take this entire power and you put it in the denominator. The -1 becomes +1, and you're left with a 1 in the numerator. And then when I simplify this, this is just 1/4. So that's the work I did to go from this step to this step. We're going to move on, unless there's another question, to x equals 0. This one's really easy, x equals 0, because that rule is always the same. F of 0 equals 3 times 4. And then getting the pencil tool to the 0 power. What's anything to the 0 power? It always equals the same number. 1. It's 1. Okay. Now, if you think about the rule, anytime you multiply by 0, you always get 0. That's true. When we have powers, anytime you raise something to the 0 power, it's defined to be 1. And there is a way to prove that. If you were interested in seeing that, I don't have time to do that right now, but I could show you that later. Just remind me. It's always 1. So 3 times 4 to the 0 power is 3 times 1, which is just 3. Okay, so that's our next ordered pair that we're going to plot, 0, 3. 0, 3. So 0, I'm right at the origin. I'm going to go +3. Remember, that's just slightly higher than where we were before. I'm never going to get all these points to be the same. Let's get done with this lesson first. Okay, yeah, I agree. Now we're going to go to f of 1 and type in this one. Purple. Everything is resizing on me. F of 1 equals 3 times 4 . to the power 1. Okay, anything to the first power is always, it's just like anytime you multiply something by 1, you always get the same thing back. Anytime you raise something to the first power, you always get the same thing back. So 4 to the first power is 4. 3 times 4, 12. Okay, so that's our next ordered pair. We have when x is 1, f of x or y is 12. All right, so I'm going to go over to where x is 1, and then we go up to where y is 12. So this is 7.5, this is 15, and it's approximately about there, okay? And then we have one more value of x to plug into the function. F of 2 is equal to 3 times 4 to the second power which is the same as 3 times, what's 4 squared, guys? What's 4 squared? 16. Awesome. And then we just have to multiply 3 and 16 together. Anyone know that one? $48. It's okay. 48. All right, now we have our last ordered pair. I'm going to plot this last point. When x is 2, I go up to 48. Look how far up I jumped. I jumped up so much further than I did before. So I'm above 45. Yeah. So as these x values increase by 1 each time, our y values, our f of x values, are increasing exponentially. This is why this is an exponential function. Okay. We just now have to connect them with a smooth curve. Because this isn't a discrete function, okay, we had that on right here, discrete functions, okay, consisting of isolated points. That's not what this is. Our domain is not restricted today. So the domain is all the real numbers, which means x covers, it's all the x values. And so we're going to try to draw a smooth curve and see how well that turns out. So you want to definitely pass through your points. And then you're never going to actually get to the x-axis. You'll get close to it. Okay, that's as smooth as my curve is going to get here. And we're going to fill in what is A, what is B. Remember that our function, its general form, f of x, is equal to a b to the x power. So just comparing this with this, what is A, what is B? Let's see how we're doing here. I'm going to come over here and show some of your work. All right, show responses. See, does anyone figure out what is A and what is B? You know, it's probably definitely complicated writing on these slides a little bit. I get that. But as long as you're trying, I'm happy. I'm happy that 11 of you are trying. Where are the other 14 of you? What are you doing? So Angel typed it in the chat. And he's right. It is 3 and 4, okay, because A is the first number, and I see it here, it's 3. Okay, so A equals 3, and B equals 4, just based on where they are, okay? 3, 4, A, B. Y-intercept, there's lots of ways to find your y-intercept. I want to remind you that what it is, the y-intercept tells us where the graph crosses the y-axis. So when it says what is your y-intercept, it's asking you, where does the graph cross the y-axis? And let's go see where it crosses the y-axis by just looking at the graph. That's one way to do it. Here's my y-axis, and here's my point right here. That's where it crosses. That's also found over here when x is 0, f of x, or y, is 3. So my y-intercept is 3 for the ordered pair 0, 3. Last thing here, end behavior as x approaches infinity. Okay, try to use a different color. Use some yellow. So as x approach, oh, that is not yellow. As x approaches infinity, y is approaching what? So we're talking about as we move along the x-axis in this direction, what is happening to our y's values? Further out x gets, the greater y gets, and this continues on forever. Y approaches infinity. Okay. Now, in the opposite way, as x approaches negative infinity, what is y doing? So this direction, as the x values go towards negative infinity, this is negative infinity. Over here was positive infinity. These y values are getting closer and closer and closer to Angel says 0, 0, 5/10 question mark. That's one of those. Mauricio says 0. Oh, that was earlier. Just 0. It is 0. Okay. Remember I said that? So like, here's your x-axis, right? And we're getting closer and closer exponentially to this. And like every time I'm getting a certain fraction of the way closer and closer and closer, but I'm never actually going to get to 0. But that's what I'm approaching. So yeah, 0, 0. All right, so I'm going to leave that there so you can finish copying that. That is the last slide. I'm going to stop recording.